Hello viewers, welcome to the series on convolutional neural network. And finally we have reached to the image recognition in neural network. So without wasting much of our precious time, let's dive into the hands-on session of the same. Now that we have trained our neural network, let's use it to look at new images and make predictions. When we pass an image through our neural network, it's going to return a likelihood for each type of object it was trained to recognize. In order to decode those numbers into names, we need a list of names that corresponds with which each number. Here on line number 8, I have already listed the names that were used during the training process. These names correspond to the 10 different types of objects that were in the CFA10 dataset. Now we are ready to load the neural network. First, we need to load the structure of the neural network itself. One option is to write out all the code for all the layers of the neural network again, as long as we match what was used during training. But it's a lot easier to load the neural network structure from a file instead. Here in the file list, we already have a file called modelstructure.json. This file contains the list of layers in our neural network and all the details about how they were hooked together. In line 22, we loaded the text file into memory by creating a new path object that represents the file that we want to load. And we have passed in the name of the file that we want to load, which is modelstructure.json. Then to load the file, we call file.readText method and save the result to a variable. Now that we have the file in memory, we need to tell Keras to rebuild the model using the data. Keras provides a helper function to do this by using the method model from JSON. So we can refer the line number 26 right here, where we have passed in the model structure variable that we just created. So far, we have only restored the structure of the neural network. To restore its training as well, we need to load the weights file we created when we trained the neural network. Here in the file list, we have file called modelweights.weight.h that we created when we trained the model. To load it, we will just call model.loadWeights and pass in the file name, which is reflected same in line number 29. Great. Now the neural network should be ready to use. On line number 32, let's load a image file. To load an image file, we can use a Keras helper function called image.loadImage method. Then we just pass in the file name to load, which is aeroplane.png. This is the file that I have randomly selected from the testing dataset of the CFA10 dataset folder. We have seen that we are not at all including the testing. This is used for prediction and to check the validity itself, right? Mm, So after that, and also we need to tell it to resize the image to the size of the neural network expectation. So we trained this neural network with images that were of 32 by 32 pixel. So that's the size we need for any image that we feed into it. To do that automatically, we can pass in the parameter here called target size, and we have to pass in the array as 32 by 32, right? Great. Now that the image data is in the memory, we need to convert it into a three-dimensional NumPy array so that we can feed it into our neural network. There's a helper function for this too called image2array method. So let's go down to line 35 then, where we have implemented the image2array and we have passed in the image variable that we have just created. Now this image is ready to be processed by the training neural network. Right now we are only testing one image with neural network, but for efficiency reasons Keras lets us pass batches of images at once. Okay, so we have seen that we were just passing one image, that is aeroplane.png, to the trained neural network. But Keras lets us pass in batches of images at once. So we can run more than one image through neural network at a time. So we need to create a batch of image to pass in, even though we were testing on only one single file. Keras expect these batches as the four-dimensional array. The first dimension is the list of images, and the other three dimensions are the image data itself. Since we only have this one image, we can turn it into a four-dimensional array by adding a new axis to it with numpy. We can do this by calling a function called numpy.expanddims and passing the name of the array that we have reflected in the line number 38, where we pass in the image to test variable we have just created. We also need to pass in the axis equal to 0 to tell it that new axis is the first dimension. This is the convention that Keras expects. Now we have a batch of images that we are ready to feed into our neural network and get the prediction. To do that, we will just call model.predict, which is reflected in the line number 41 right here. And we have to pass in the list of images we have just created. The results variable will contain a list of results from each image that we passed in. Since we only passed in one image, we can just grab the first array index. And to do that, we have to follow this syntax. The single result array is an array with 10 elements. Each element represents how likely the image is to belong to each of the object types we listed at the top of the program. Instead of returning 10 separate numbers, we just grab the array element with the highest value. That will tell us which single object type was the most likely result. We can do this by using numpy's argmax function and then pass in the single result. We also want to convert this to an integer, so we will wrap up it with int function. While we are here, let's also grab the likelihood value of the array index so we can print it out later, where we passed in the most likely class index. Finally, on line number 51, we are looking up the name of the object type from the list of class labels and pass in the index that we just created, that is most likely class index. Now finally and lastly, on line number 54, we are just printing out the results. So without wasting much of our time, let's try to build it and see how it predicts the aeroplane.png file. So you could see it's running. Well, let's hope for the result. And yes, you can see here the image file that we have randomly selected from the testing set. Let me open it to let you know. See this image file, it has predicted it to the plain class, right? Similarly, we can do, I have uploaded one more image here, truck.png from the testing set. So let's try to look the same result with truck.png. Okay, let me rerun the same chunk of code. So yep, great. So it has successfully classified it as also truck. So I hope this video was quite interesting to you, how to recognize the images using convolutional neural network. I hope this video proved fruitful to you and hope you have gained something extra than what you were knowing earlier. Thank you.